Hi, I'm Patrick Bay, the creator of CypherPoker, and I have some exciting project updates to share with you. For starters, I'm very pleased to announce that a functioning proof-of-concept integration between CypherPoker and Ethereum is now complete. If you're not familiar with Ethereum, it's a blockchain-based, decentralized smart contract platform. You can think of it as a giant distributed computer that's powered by the Ether cryptocurrency, which, incidentally, is currently second in market cap behind Bitcoin. In CypherPoker, Ethereum is used to provide game verification and escrow services. Well, okay, technically Ethereum smart contracts are powered by gas, which is purchased with Ether, but I don't think we really need to get too technical in this video. I would, however, be happy to get into all the gory details, or to talk about how CypherPoker fits in with decentralized autonomous organizations, or to discuss strategies for incorporating cryptocurrencies like Bitcoin, or to, just shoot the breeze, over at CypherPoker's shiny new Slack, which you can access via the shiny new site at cypherpoker.org. While I'm here, I should also point out that I'm using the Issues section in the CypherPoker GitHub repository to log some help wanted items that will need to be completed for future releases. They range from the creative to the technical, and I've included as much detail as I could think of, so drop by and see what you can sink your teeth into. Okay, enough plugs. Let's demo! Here I'll be using 2 instances of Ethereum and 2 instances of CypherPoker in order to mimic real-world usage. The Go Ethereum client, as you can see here, is the 1.35 or Homestead release for Windows. The top client window is set to accept incoming RPC connections on port 8545, and the bottom Ethereum client is listening on port 8546. Over here, we have the 2 proof-of-concept CypherPoker game instances that, as you can see in the URL, are communicating with Ethereum using the RPC ports on which the clients are listening. Because we're going to be playing a cash game in which players send Ether to the smart contract throughout the game, I'm going to check each player's balance before we start. The balances shown here are in Wei, but in the game we use Ether, so let's see what the equivalent values are. Now we can start the game by entering a private game identifier, which will create a new table just for the 2 players. Once both players have joined, we can start the game. During this phase, the 2 game clients are playing a cryptographic version of Rochambeau, or rock, paper, scissors, to determine who the initial dealer is going to be. Now that the dealer has been established, we have to wait for the smart contract for the upcoming hand to be mined, or added to the blockchain. With the poker hand contract mined, The game clients now automatically deal the cards and post the required blinds. After that, the players take over. Let's check that the contract has received the required ether from the blinds before continuing. We do this by first opening up the browser's JavaScript console and copying the contract address from one of the latest function calls. The address is usually the first parameter. Next, we check the balance of the contract in the Ethereum client console, as we would with any other address. Let's see what this value is in Ether. As expected, the Ether currently being controlled by the smart contract matches the size of the game's pot. Okay, let's play the hand. Almost everything that you can see in the game client is customizable, including the amount by which bets are increased or decreased. I've decided to use the large increments of 100 Ether since there's plenty to go around. Now that the game is finished, we only need to wait for the smart contract to finish up and pay the winner. This takes a few moments since smart contracts are only updated whenever new blocks are mined, and on the main Ethereum blockchain this takes between 15 to 20 seconds. Even on a private blockchain, it can take a few moments. Now that the winner has received their winnings, we can double check that the contract has been emptied out. Great. The new dealer has mined a new contract for the hand, so let's play another round. Unfortunately, this player has decided to fold. As with previous results, we have to wait a few moments for the settlement to take place on the blockchain. Both players could keep playing this way until one of them has exhausted their supply of Ether. An alternative to this type of play involves a single buy-in by the players, which eliminates the need for individual transactions during the game. Since each transaction has a slight cost associated with it, a game with a single transaction will always be cheaper than a game with numerous transactions. Both of these options, as well as many others, are available in the CypherPoker game client and only need to be implemented in a nice user interface. In fact, the proof of concept integration demonstrates that CypherPoker is fully feasible, which means that there's a wealth of contributions that can be made to the project. And by that, I mean contributions by you. Contributions shouldn't go unrewarded, but the details of how this and other functions are handled within a decentralized autonomous organization model are currently open discussions. So visit CypherPoker.org, join the Slack, and let's talk about how we're going to shake things up.